Hello, everybody, and welcome to PyData Global 2024. Thank you so much for being here today with us and taking time out of your day to come hear Alonso's talk. We're so thankful for Alonso and all the speakers that are giving their time and energy into PyData Global and into the PyData community. So, Alonso, thank you so much for being here. Attendees, please feel free to use the chat feature. It should be on the right side of your screen. And also there will be time at the end for Q&A, and you can drop questions in the chat or in the Q&A tab, and we will get to those in the last few minutes of the talk. But right now, I don't want to take up any more time. Alonso, the floor is all yours.
Okay, thank you. So today I'm going to present building knowledge graph-based agents with structured text generation and open weight models. And first of all, I want to introduce myself. So I'm Alonso, and I'm a researcher at generative AI at Nokia Bell Labs. I also work as consultant and trainer. I have a PhD at INRIA and a postdoc at Berkeley. And I'm currently based in Paris, France. And here are my socials if you want to connect. I put the slides in the resources, so you can check them there. And also, this presentation is actually a Jupyter notebook, so you can watch also the Jupyter notebook, which is there. So let me introduce the problem. So what's the problem we're going to deal with? So one of the problems I'm going to speak at the beginning is going to be about the structure generation. I'm going to mention, for example, this is just one library that I'm mentioning, which is Scikit LLM. I mean, this library exists. It has a good number of GitHub stars. And basically what they are doing is they are trying to use LLMs in order to classify, for example, a text into a set of categories that you're going to give it. Okay, for the sake of example, let's consider the most simple example, which is sentiment analysis. And you want to classify between a sentiment which is positive or negative, a given text. Of course, this may be the less interesting example because more generally you want to have several other categories. But okay, let's start simple. And what they do, this is an open source project, so you can look at their prompts and you can look at what they are doing. And I'm going to just focus on this part in which I say, okay, they are asking the prompt, they are asking the LLM to provide a response in JSON containing a single key label and the value corresponding to the assigned category. And why they are doing that is because downstream you want to work, for example, you're giving a data set with 1,000 pieces of text, and you want to work downstream. And the easiest way to do that is to work with JSON. And here this is the part that I'm going to talk about, which is they also mentioned do not provide any additional information except the JSON. And this is because the LLM is going to try to first speak to you, and he's going to say, okay, here's the JSON you asked for. Or he's going to give you the JSON, and then he's going to start to explain this JSON does this and that, etc. And this will work until it doesn't, but actually we can do better than this. So I'm going to mention first what is not structured generation, because this gets very confusing sometimes. And for example, I'm going to give it another name, which is structured output to the in the style of the instructor or Marvin libraries. And basically what they are doing is a little bit different. Okay, the names are still under discussion, and the dust has not been settled in the LLM world, so we don't know how this is going to be called. But what they are doing behind their back is to use a particular thing which is called which is doing is function calling. And in particular, for example, here I'm just going to show it in code. Here I'm defining one LLM. I'm taking one LLM. I'm taking Hermes 3 by New Research. I'm using Llama CPP through Llama CPP Python. And I'm going to define a fake function. And this function is going to be called the sentiment function. And this function will need an argument, which is going to be called the label. And the label, this argument label can be either positive or negative. And what this argument requires is the sentiment of the text. Actually, you can build out from a Pydantic class, you can build out this function. This will be a function that the LLM will see. So this in reality is the string that the LLM will see. And you can see here that what he's asking the LLM, he's going to try to call this function with this parameter, and the parameter that he's asked for is a label, which can be positive or negative, and the description will be the sentiment of the text. So they do that, and thanks to that, they can, so the user will input this, for example, you are great. Through prompt engineering, you're going to say, what's the sentiment of this text? You're going to get here. And through function calling, you're going to structure the information, and it's going to try to query that fake function, and it's going to get this label positive. And this is very smart, and it works very well until it doesn't, because the LLM is not deterministic. So in any case, it will not be perfect, and we can do better. So what is structure generation? So I'm going to use in particular this library, which is outlines, but you can use the library that you prefer to do this, guidance, etc. But what is important to notice here is an observation is that LLMs are samplers. So for example, when you input text here, never gonna give you up, never gonna let you, the LLM will try to predict what will be the next word, but it will give you the whole probability distribution over all the tokens, over all the subwords that are possible for that particular LLM. In particular, for a big LLM, it's around 100,000 possible tokens. So he will go to give you the whole list of probability, and for each, it will give you a certain probability that he will take the next word. So it's important to know that. So you are taking samples from from the text. And also I need to talk about regular expression, but please don't leave the session. So it's going to be very simple. I'm going to consider the regular expression A star B star. So let's consider that I only accept words of this type, A star B star, sorry, which matches 0 or more occurrences of A, or 0 or more occurrences of B, considering B after A. Okay, if you consider that regex, which is very simple, you can also write it in the following way. You can consider here, this will be the input when the word enters. This is going to be the states. And you're going to consider, for example, if I write, and the double circle means that all of these are accepted. So if I write 4 times A, I'm going to stay in state 0, and this is going to be accepted. If I write AB, it's going to be accepted. If I write ABB, it's going to be accepted, etc., etc. But this will not, once I arrive to this state, so once I do B, I cannot go back to A. And this completely determines what will follow. But LLMs don't work with characters, they work with tokens. So we will need to determine from the tokenizer, we will need to determine which are the tokens that allow us to stay and to leave to another state. So for example, let's consider here that this is the tokenizer that was provided for that particular model. So here we have all these tokens, A, etc. And here we have all these other tokens, which allows you to move from state 0 to state 1. And once you move to state 1, you're going to only consider these are going to be the acceptable tokens. And as I mentioned, so if you start with from state 0, you can do A, 4 times A, sorry. You can do 2 times A. But once you do AB, once you have taken that token, you should not be allowed to do anything else than to use these tokens, B and BB. So in that case, what we should do is to consider to put a mask, for example, to put all the other tokens to 0. The probability to take all the other tokens will be 0, and the only tokens which will be allowed are going to be these 2. So this is basically what Outlines is doing behind your, for our behalf. And if we go back to our original problem, we were asking this kind of question for the JSON. To ask this in JSON format. And if we consider the simple example of sentiment analysis, what we are asking in reality is to get these regex. So the regex that we're asking is, okay, I'm not worrying yet about the white spaces, but if you consider removing the white spaces, you will consider label positive or negative. And the only path, the only part in which the LLM should make a choice should be this, positive and negative. However, life is hard. We don't work with the words, we work with tokens. So the outlines need to take care of all of these things. And for example, here, this part is about the label, this part is about positive, this part is about negative. If I just look at the part of the label, All of these are writing exactly the same thing, which is the beginning, then label, and then it will follow the rest. But but for us, this string is the same. They are all the same when we arrive to state 7. But for the LLM, they are different because there is a history here. This token, the tokens that he took here are different than the tokens that he took in this other path. And this will determine that the probability distributions of this will be different. So we need to consider all of them. But in code, it's much simpler actually than all this thing. So in code, what outlines will do for us is going to be, you basically provide a tokenizer. So in this case, we provide the tokenizer from the model that we gave. We are going to tell it what's the class, the pedantic class that we were using. In our case was sentiment. And here is where I'm going to talk a little bit about white spaces. So you can provide, you can also give outlines, which are the white spaces that you accept. So here I'm going to accept white spaces, tabs, and line breaks. And I'm going to give the possibility that he can use this as many times as he wants. So this is not the default by outlines, by the way. The outlines default is just one space. But I like to give more leeway to my language model. Okay, and in that case, what we're going to have is that when the user inputs this, you are great. You're going to put in a prompt what is the sentiment conveyed by that text, and you're going to constrain the model to fulfill these regex that I mentioned. So he will comply and he will give you this. But there is, so here what we are what the model is being forced to do is to fulfill this, to put either positive or negative. But he's not forced to give you the right answer, right? The right answer, he should determine it by himself. So still, even if he will give you a JSON and he will still give you a correct JSON 100% of the times, what you would like to do is to encourage it to give you a good answer. So the way to do that to me is to mix both. So you can consider structured outputs and structured generation both. And in that particular case, it's going to be very simple. It's going to be just considering the function that we define it, and then also adding the outlines logic processor. And with this, we are encouraging that this is correct JSON. I mean, we are forcing the model to give you a correct JSON, but also we are encouraging it to give you a good answer. Okay, and now I'm going to pass to the part of knowledge graph generation. So we're going to use what I mentioned before to build graphs. And this will, for the storing this graph, I'm going to use Kutsu to store this in a graph database. This is going to be, it's very nice to use Kutsu because you can pip install it, you can try it, and you will see if you like it. But it has all the features that I need. If I consider, for example, a text, now I want to build a knowledge graph from this text. Let's consider this text. It's around 1 page of text. It talks about Marie Curie. And the first thing I'm going to do, I'm going to cut it into pieces. Here I'm just cutting it into paragraphs. Of course, for more complex things, you can do some more complex chunking. And now I'm going to, for each of these paragraphs, I'm going to build a knowledge graph. And the way I do this, I'm going to bake a fake function. And for this, I'm going to build a pedantic class called nodes, in which I will consider the ID, the type, and the label, and an edge, which will consider the source, the target, the type, and the label. And then the knowledge graph is going to be nothing else than just a list of nodes and a list of edges. And then I do the same as before. So I convert this fake, this pedantic class to a fake function. And now a little bit of prompt engineering. I tell the model, okay, you're a world-class model who answer question in JSON with correct pedantic schema. Here is the JSON schema you must adhere to. I provide the schema. And then I just say, okay, describe the text as a detailed knowledge graph. And I use both things again. So I use structured outputs and structured generation. And thanks to that, the model will be able to provide a decent, reasonable knowledge graph. So for example, just to test, Here I'm taking the messages, calling the LLM, and filtering out the answer. And if I get Alice loves Bob, for example, he will provide me a list of nodes, Alice Bob, and a list of edges, which go from 0 to 1. What's the type of node and what's the label. Okay, and I'm going to do this for the 4 chunks that I divided my text. So for each text in text, I'm going to just store it in nodes and edges. And now I'm going to get some good number of candidates for types of nodes, and good candidates for types of edges. And I'm going to go to the expert on this field. I don't know, for example, if I'm taking for a text about law or about medicine, I'm going to tell you, okay, this is what the LLM is suggesting. What do you think? And he will say, okay, perhaps person is a great node type. But here I will, instead of country, I will consider location, and instead of element and chemical element, I will consider what's the discovery. And similarly for the edges, he can tell you the same. And with this, the only change we need to do to our previous code is to, instead of consider the type of the node to be a string, now we are going to force it to be one of the things that the expert mentioned. For example, here, the LLM, we need to do person, award, discovery, location, or other. This other, I'm putting it to then discard it, by the way. In case the LLM wants to put something, he can put it there. And similarly, I can do the same for the edges, and that's the only code that changed to my previous code. And this will provide me a decent knowledge graph for here you can see how to visualize it, but this is not important. So, okay, for example, here, when Marie Curie came to the United States for the first time, so here the LLM will say, okay, Marie Curie, and here visited location, United States, coined the term radioactive. She discovered the elements radium and polonium, so here it's discovery. And similarly, she won the Nobel Prize twice. And here, the LLM added some note that I did not like, which was he put person, Marie Curie, location, Paris, and here he put interpersonal relationship, spend most of her time. So I guess he was related more towards relationship, but still this is not very important because I will discard when I'm going to select the edges. Basically, interpersonal relationship should be between person and person. Similarly, visited should go from person to location, and discovery should be from person to discovery. So this is not very important, and you can consider the other chunks here. You can see. And once I have this, I can put this into a data frame, into data frames, and this you can also do it immediately, but I like to put them in another data frame, and then I'm going to put it in my graph database. Okay, so in Kutsu, you first connect to the database similar to SQL. So you create a connection, and then you're going to create a schema for each of these things like person, award, discovery, location. And you're just going to add these data frames to the graph database. Just to check that things are working, I do this. So this is similar to SQL. You get match person, return person name, and you get all these person names from the database. So it seems to be working. And similarly, I can insert the edges. And here, this is what I was mentioning before. So this is why it looks a little bit messier, which is I'm checking that indeed an award goes from person to award, a discovery to go from person to discovery, etc. Okay, and I can check similarly that the edges were well input. So this is working correctly. So sorry for that. And if I go now to the part of agents, so what is an agent? Basically, an agent is going to consist of the LLM will receive a task. He will reason about that task. He will generate, for example, a query to the graph database, and he will get an answer from that database, and he will get an answer. And this he can do many times as he wants. Okay, and in the previous case, when we were building our knowledge graph from the text, we were somehow forcing the LLM to follow a JSON which will fulfill this requirement. But here we are going to ask to use structured generation to do something completely different, which is force the LLM to reason in a certain way. So first I need to define some tools that the LLM can use. So one is going to be the query checker. This is just prompt engineering to check a prompt, a query. So for example, here, the only thing I do is if I write a query like this, and I added these mistakes, I hope the LLM will fix them. And indeed, he fixed them. So here there was missing an entity, and here it was missing, this was badly written. And similarly, I'm going to build provide another tool, which is going to be the query generator, which basically I need to, in order for him to build a good query, I need to provide it a schema. Here I'm taking it from LangChain, but once I have this string, I can forget about LangChain. Okay, and now I can put this schema here. And this is just to, this is, by the way, similar, the same as LangChain, the same prompt to generate a Cypher query. And here, the idea is that if I now ask the LLM, what discovery is Marie Curie famous for, the LLM will be able to get a Cypher query, which will query the database with the Cypher query. And in particular, here I'm also executing what his. So here, if you see, here I'm also executing what the LLM, the Cypher query the LLM gave me. And in particular, here I'm getting this answer. And the last tool I'm going to provide is just answer normally. This is just for the LLM to have another tool as an example. Okay, and now what I'm going to do is going to force the LLM to follow this fake function, which is going to be thought, action, and action input. And I'm also providing it as scratchpad. And basically, the LLM will need to fulfill a sort of JSON in which he will need to give me a thought. He will need to give me what's the action he wants to take. And these actions can be only one of these three actions. So conversational response, query generator, or query checker. And the action input, which needs to be the argument of that action. And a final answer, which will be the answer to the question granted of the observation. And here, I also provide the possibility to use a scratchpad. And finally, the LLM will need to make a decision between entering into this loop, reason and acting, and a final answer. Okay, and now I'm ready to do that. And here I'm using another possibility, which is to use to wrap the LLM directly into outlines, but you can do it as I did at the beginning. And here I'm doing a little bit of prompt engineering, in which I'm going to say to the LLM, okay, you're running a loop of scratchpad, thought, action, action input, observation. At the end of the loop, you need to output a final answer. And here I describe what will be, sorry, here I'm going to describe what are these action. Use action to run one of these actions, etc., etc. So it's a little bit of prompt engineering. But the idea is that now the LLM will be able to run through these loops, and he will be able to decide. Okay, and here I define a chatbot class. And finally, here this is just, I provide to this chatbot all these possibilities, and I'm going to do, when it's taking one of these action, I'm going to run this action. So that's it. And perhaps the most interesting part is to do it, to see it online. So here, for example, if I do query the database to see which discovery did Pierre Curie do, the LLM will give you a thought. So his thought is to find out what specific discovery Pierre Curie made. I should query the database for information related to his work. So he will run the query generator. He will get this Cypher query. He will run the Cypher query against the database. He will get piezoelectricity. He will write into his scratchpad, okay, Pierre Curie discovered piezoelectricity, and he will provide the final answer here. So finally, if you want, you can hide this from the user, and you just provide the final answer. But I think it's also interesting to see what the LLM does. Similarly for Marie Curie, and you see here the answer is very similar, but the answer here it's different. It's radium and polonium, and here if I ask it to tell me a joke, he's going to provide a joke. Okay, and if conclusion, so structured output plus structure generation help us to generate knowledge graph from unstructured data, and at the same time it also helps us to create these agents which can then query graph databases as well as calling other tools. In this particular case, I just use a very simple tool, which is conversational response, but you can provide a Python script or you can provide any other tool that you want. Okay, so the references for this talk has been coalescence. Here is another one about how to do the coding with regex. And this is a simple implementation of React. And for this presentation, I have used Kutsu as a graph database, Llama CPP for inference, Outlines for structured outputs or structure generation more, LangChain, and Solera visualization. But LangChain, again, I use it very sparsely. I just use it for getting the schema. And if you want, you can give anonymous feedback at this website to help me improve my presentation skills. Thank you.
No, man. Thank you. We do have some questions,
Yes.
and I will bring them to the stage.
Yes, so the question is there a constraint on the length of the prompt when you use the outline finite automata algorithm? I don't think that there is a constraint, it's just the time it takes. So in this particular case, for example, for knowledge graph, so it's the only thing that it takes time is at the beginning, it's the first time. So when you are going to build this, it can take a few seconds. And in particular, if you take, so in some cases, it can take, I don't know, 20 seconds. In this particular case, time was not the main constraint to generate knowledge graphs. And similarly, to create a React agent, you can think, okay, I'm going to create this index to do this the first time, but then I will use it without delays. Okay, so exactly. So for extracting nodes and edges without using LLMs. Okay, so one thing, you can do it yourself, of course. And actually, I have a presentation at PyData Paris in which I do it without LLMs. But I think LLMs help. And in particular, I know that there exists already some LLM graph transformers for LangChain and for Llama Index. But in my particular experience, they are not that good. And when I want to modify something, it is very complicated. While in this particular case, as you saw, you have like a few prompts that you can modify if you want to change it. And I think that here you are more in control of what you are doing.
All right, we have one more.
Sure. Okay, exactly. So I to be honest, I'm going to promote my PyData presentation in which I gave enhancing RAG with GraphRag. And basically, yes, I in that particular presentation I use GraphRag.
Awesome. Fantastic. Thank you so much.
Thank you.
For your time. Thank you, everybody, for joining us today. You are welcome to continue the conversation in Discord. Alonso, thank you so much for being with us today. We appreciate you.
No, thank you to you.